Welcome to Tidy Explained, a screencast where we explain our code for you, the listener, to help you understand what's going on. My name's Patrick Ward. I do data analysis in sport. You can find me on Twitter at OSPPatrick.
And my name's Ellis Hughes. I am a statistical programmer, and you can find me on Twitter at Ellis_Hughes. You can contact the both of us a couple different ways. We have a Twitter account for the screencast. It's at tidy_explained, or you can email us at tidy.explained@gmail.com. Alternatively, leave a comment in the comment section below. We love it when we hear from our listeners. We love hearing ideas. We love hearing, just what you're getting out of this. So please definitely leave a comment below or add us. We love hearing from you. All right, so episode 31.
Yeah, episode 31. We're really excited about this one because as those who frequently view the screencast know, we often follow up a Tidy Tuesday entry with our own sort of sports version. And this week's Tidy Tuesday was all sports. So one of the things that we had discussed was, man, we really want to get into Reactable. We've done a few TidyX episodes with tables. We've done a little bit on, we've used GT a little bit. We've used DT a little bit. We've used Knitter a little bit.
Yeah,
I think we might have even used Cond format once. So we've done a few table things.
There's a lot of great table packages.
A lot.
And tables are a data viz tool.
They are.
Table are data viz.
Extremely useful, and they're all a bit nuanced. And the one we wanted to get into was Reactable, because we wanted to kind of like understand a little bit about how it works. And it looks like, which you'll see as we go through this, it's super flexible. So as with anything, you take the good with the bad. While some of the other table packages have lots of useful functions that things are pre-built and you just sort of feed it data and you get a table returned, Reactable might take a little bit of a learning curve in terms of the coding things and how you want things to look, but it's super reactable to whatever you want it to do. So let's go ahead and load in our libraries and then get to the sports data set, which is a cool data set.
All right, let's do that. All right, so we've got our, we're using an R Markdown as we tend to do. We like the formatting so we can run each line of code. We can, author attributes. There we go, English. All right, so setting the Knitter chunk. So by default, it'll echo. We're gonna load in Tidyverse, the data manipulation extraordinaire. Tidy Tuesday R to help us get our data into our R session. Reactable, which is the highlight of this week, and then GG Ridges for a plot that we're going to take a quick look at as we are starting to explore the data set. Sparkline and Page Table, which are two different packages that kind of Sparkline creates Sparkline plots, and then Page Table is a package that I wrote with the help of Javier Larashi to generate page tables, and you'll see what those are in a second. And then we're also, by default, as we always do, setting our theme to be theme light so that we don't have to go and set that to all our GG blocks. Awesome. So I'm going to run this. So this is TT load. This is from the Tidy Tuesday R package. We set the date of the data that we want to be pulling from the Tidy Tuesday repo from. And then, so now it's downloading all that data. So I realized that I'm actually kind of a little bit zoomed out. So I'm going to zoom in for y'all. All right, so now we've got TT. So that is the TT object that comes out of Tidy Tuesday R. When you print it, it prints the data sets that are available to us, as well as the README in our little viewer over here. So this week's data set, which is what we're pretty excited about because we normally do sports themed type examples. I think Alex Cookson pointed us, like, he was super excited about seeing us do this. So thank you, Alex, for calling us out on that, is the NCAA Women's Basketball Tournament data. So we both saw this and we're like, ooh, this could be fun.
Yeah, lots of options. And I think the other thing, too, for people who are kind of watching and getting started in R, the nice thing about this week's entry, or this week's data set, not only is it sports related, so it's fun to work with, but it's also one single data set, and it's relatively clean and So there's not a lot of like legwork that you have to do to sort of pull it in and get started with like visualizing things and doing some aggregations of data and just like querying the data in different ways. So this is a really useful data set to, I would say, like if you're just getting started in R, it's probably one that you also want to, do a quick like write to CSV and keep it on your desktop to like, there's like a few data sets like that I always keep that I like when I want to learn something new, I just like pull that data set up and I work on it.
Yeah, it's a little bit better than working with like empty cars or a little bit more interesting.
Exactly. Well, the Massachusetts housing data or whatever.
Yeah. And also the data dictionary for this data set is very, very good. There can be a lot of information contained in fields here, but the way that they laid it out is actually fairly wide. So they're able to have a lot of information here that you're able to kind of extract and pluck out and kind of go through. They really, Thomas or whoever submitted this to Tidy Tuesday really went through and added a lot of information like tourney finish, but there's a lot of different levels to that, and they actually explained, ours opening round loss, first round loss, and so they really went through and really defined it, because I would not have guessed that RF meant they lost in the Elite Eight. That was not the first thing I thought of.
Yeah,
I had no idea what that meant. So
yeah, totally, yeah.
So that's awesome that they've got that. All right, so now we're going to go through and extract it. Tidy Tuesday R, the way you do that is $TT dataset you want to keep. So we're pulling it out. We assign that to NCAA. So there we go. Big old data set. 2,000 over 2,000 rows, 19 columns.
Yeah, we're going back. It's pretty far. What was the earliest year for women's NCAA tournament? Which actually the earliest year might not even be in this data set, but I wonder what year they have.
Pull year min 1982.
82. Okay, maybe that's the first year that the tournament ever happened, or maybe it's the first year that they have data. Perhaps.
Yeah, I bet you that is not the first year. NCAA Women's Basketball and Ball History. Bring that over here. Oh, it was inaugurated in 1981-82.
Oh, there you go.
There you go.
Wow,
so this is literally all of it.
It is literally the entire thing. That's cool.
Yeah, there was the AIAW Women's Basketball Tournament, which was held 10 years prior, or started 10 years prior. But we have all the data available to us.
That's awesome, yeah.
Sweet. Alrighty. Patrick, you want to take us through the next couple steps here?
Yeah, we always kind of leave this stuff in. It's me always messing around whenever I get the data set. I like to play around and see what's there. So quick view of the top. Some people do view and they pull the entire data set through. I always just pull the head because I just want to see what do the columns look like, what do the data look like, type of thing. So that's sort of my preference, but certainly not everybody's. Then a little bit of just kind of exploring the data. So how many conferences are in the data? I just wanted to kind of take a look and do a quick count. So really, really quickly, as you would expect, obviously, there's the Power 5 conferences, but really there's 6. So it's Power 5 plus 1. They still call them the Power 5, but it's Southeast Conference, ACC, the Big 10, the Big East, the Big 12, the Pac-10. Those are the main conferences. So that makes total sense. I just kind of wrote a note in there to myself, and I think in the next chunk, I just decided, you know what? Let's just lump those 6 conferences that are called the Power 5 conferences together, and then.
So there's been some conference name changes.
Yeah.
Did they fix that? Sorry, I just thought about that.
Like, what example were you thinking?
Like, the Pac-10 is no longer the Pac-10, it's the Pac-12.
Oh, yes. You know what? I think actually, if I remember correctly, I think I did check that in here, and it was always the Pac-10 still.
Pac-10, Pacific Coast, Pacific West.
Yeah. Oh,
Pac-12.
The Pac-12. Oh, interesting.
There we go. So there is some...
So let's put that into our little lump there then.
Then we'll have to do, where there's the Pacific sent in Pacific 10. No, numlock, you need to be on. Stop inserting now. And then the Pacific, or Pac-12.
Yes.
Were there any other conferences that changed names?
I think Big Ten, even though they have more than 10, is still the Big Ten.
Yeah.
I mean, I know there's teams that have jumped conferences at times, but I don't think, off the top of my head.
Let's quickly scroll through. Sorry, guys.
There's the Atlantic 10 and the Atlantic 10, but that's a small conference, so they're going to get lumped as other.
Yeah.
The big.
Yeah, I guess let's keep it.
What about the Big 8? Was that once the Big 10? The Big 8? Were they?
You know what? We can make a call right now that we're not.
Yeah, well, we could leave it as is, but the Pac-12 is a good catch, which probably also explains why, although it shouldn't explain why, but why I kept seeing the ASU not in the Pac-12 or Pac-10, which is bizarre because the two ASU teams actually were the teams that made it the Pac-10. It was the Pac-8, and then they added ASU and U of A. So, but maybe they'll be in now. Anyway.
Wait. So
we do a quick.
I double do that?
Yep.
There we go.
What you did there was you basically made within that mutate within this case when you said anytime it's Pac-10 or Pac-12, Pacific 10 or Pac-12, just go ahead and call it Pacific 10. And then we did another case when, within that case when, we did another step where we said anytime the conference is...
I think it's easier to be a little bit more explicit this way. Sorry I'm mixing up your logic here.
Call it other?
Yeah, because this way we can say if it's in these guys, keep
just
that
call
name.
it the conference, yeah. And then anything else, call it the other.
For my brain, I think I like that sort of thing a little bit better. So NCAA conference... Let's get a table of that guy. Wait, why is it not...
You want to do a conference lump. Conf lump was what we called it.
Oh.
So it's there we go. Conf C-O-N-F lump.
Oh, conf lump.
Yeah, this is our lumped data. So now we have...
There we go. There we go. Pac-12. We added a few back to the Pac-10. All right.
Yeah. I was wondering why they looked so low. Okay. So now let's look at the tournament appearances of these Power 5 conferences.
All right. So what we're going to do here is we're going to take NCAA lumped using conf lump, not conference, and count the number of times that the conference exists. Calculate the percentage by dividing n by the total number of conference appearances, then throw it into ggplot where x is the percent, y we're going to reorder the conference lump by percent to make sure that it's descending order essentially. Geom call, it's going to be filled with light blue, the alpha is going to be 0.7, and the outline color is going to be black. Scale x continuous, so the x-axis is going to be, we're going to use label scales percent so that it's going to scale it to percents so it looks prettier. And then set the labels, x-axis is going to be percent of appearances. We're not going to have a y label since it's going to be the name of the conference. There's no value added to actually have a label. And we're going to set the title, percent of NCAA Women's Tournament appearances among Power 5 schools. So, boom, look at that.
Southeastern Conference absolute athletic powerhouses.
Yeah.
in every sport.
Yeah.
Men's and women's, it doesn't matter. They are just dominant. It's just like athletes.
So are you saying maybe they focus a little bit more on athletics than
No, I didn't say that. That's not what I said. I just said that they have good athletes.
That was me saying that. But yeah, no, that's crazy. The number, like they double Pac-12, Pac-10.
Yeah.
The ACC has a ton of appearances there.
Yeah,
There you go.
ACC. The Big East. I feel like is so fueled by UConn. I mean, they are like the most dominant. I think the most dominant program. The Southeastern one is probably. I mean, a lot of those teams make it. They're into the tournament. They're very successful. But Tennessee, Pat Summitt's years were like absolutely soul destroying for anybody else playing women's basketball. I think they were just like super dominant teams. They just would crush it.
Yeah. Wow. That's
Yeah.
cool.
Yeah.
All right. Gonna hop over. So what are we gonna look at next?
So we're going to look at the distribution of win percent. One of the ways that these teams get into the conference is by, doing the dirty work during the season and making sure they win the games they're supposed to win. So I figured let's look at the win percentage amongst teams within conferences. And keep in mind what we're looking at here. If you go ahead and run it, when we run this, what you quickly see is our nice little GG joy plot or ridges plot. What you quickly see is all of the conferences have this win percentage that exceeds 70%. It's like around 72 or 75%. And so it's important to remember that what we're dealing with here is it's a sample problem. It's it's almost like survivorship bias. Most of the teams in the sport in women's basketball are going to have a win percentage during the regular season that's substantially lower. We're only looking at the win percentage of the teams that were actually invited to the championship tournament. So of course, these teams have very high win percentages on average. So again, the median is about 72 to 75%. And you can see some of them are a little more lumpy than others.
Bloop, bloop, bloop.
You kind of had a hypothesis about that.
Yeah. I was so because that's so this was like I was making this hypothesis when I didn't make the connection that this was only the teams that were invited, but it's lumpier because there's not an even distribution, right? So there's going to be a team that is super dominant compared to all the other ones that got invited. So like you can kind of see this, the Big 12 is a little bit lumpy here, where there's a team that had like close to 90%, or teams that are often close to 90%, and then a big lump around 70%. And so there's
Right.
that, and then like the others very, very nicely distributed, and that makes sense because that that is
with
all
a
other.
long tail too,
Yeah.
towards the left.
Yeah,
Like,
so there's
yeah.
not a lot of auto bids for those conferences. It's
Right.
got there's a lot there, but like Pacific 10, Pac-12, like they have a big lump. Same with Big 10
Yeah.
on the lower end of the median, or of the middle here. And so that would
Yeah.
mean that there are probably a lot of teams that maybe really didn't deserve to go. Like they got the auto bid or something along those
Or
lines.
they get in. It's not necessarily deserve to go. I think part of it too is they get in because they probably play a stronger strength of schedule than
Yeah.
teams in the other conferences. So,
say.
if you're in like the Mountain West, you might not be playing a very strong strength of schedule. But if you're like let's say like the Lady Buckeyes, you might lose a few games to like Michigan, Kentucky, stronger
Strong
teams.
teams.
Yeah, and so there is something to be said for the strength of schedule. The Power 5 conferences tend to play more difficult games. So sometimes those teams get in because the writers know, like, oh, this is a good team. They just played they had a really rough go.
Yeah.
The one thing I don't like about this plot that I just noticed, and I noticed it when I first made it, and I forgot to correct it, is if you look at the x-axis, I hate that it's a percentage plot that goes up to 1.1, even though there is no 1.1 in that.
Yeah.
I wonder if I used scales and changed it to percentage, if it would know to cut. To keep the distribution between 0 and 1, the x-axis rather, between 0 and 1. That is like a super annoying thing.
Let's do scales, x, continuous, right?
Yeah, either that or maybe we have to set the x lim to 0 and 1. But
What is it? Labels.
Labels equal scales,
Scales,
percent, no parentheses.
No paren.
Yeah.
Cannot find so scale x. There we go.
Yeah, scale x continuous. Let's see if it cuts it.
Nope.
That's so
It's because it
annoying.
just changed it. Well, I mean that's part of the reason too is that it's density, right? So density doesn't really it's a density plot. It doesn't know that
Yeah, that's right. Yeah, you're
like you
right.
can't
You're
get
right. Yeah.
over a hundred
You're right.
percent.
It's not a yeah, that's
It's not
right.
an
It's
actual histogram. It
yes, you're
is
right.
it
You're
is
right. You're
looking
right.
at like
There's got to be a way to fix that in that function. That's like
yeah,
that's super
I've
annoying.
seen people. Yeah, that's a common thing. I've had a lot of discussion, or I've had a couple discussions with
Yeah,
like
maybe if
stat
we
profs
yeah,
about
exactly.
that.
We could
And
probably
like
just do xlim, you know, uh, 0, 1, and get rid of the x continuous, the scale continuous, because I don't think you can have both. Oh, maybe you can.
no,
No,
but
but
then it still lops it off, and that's not.
no, but it looks. But it doesn't matter if it looks weird. It's real. That's what that's what we
That's
need
what
to
we care
see.
about here at TidyX.
Yes,
Let's be real.
yes. This is correct. It's the correct. Okay. Anyway, let's
All
move on.
right, moving on. Sorry, we got a little distracted there.
Yeah.
Alrighty, so now we're gonna get into what we started this screencast today about.
Yes.
Reactable and the tables. Alrighty.
Yeah.
So there's a little bit of prep that we did for our table today before we throw it into Reactable, just to kind of get the data set up the way that we wanted it to show some of the cool pieces of Reactable that exist. So what we did is we took the NCAA lumped and we selected the fields that we care about to be throwing into the table. So school, what year, the seed that they had, the regular season win percentage, the tourney win number of wins, tourney number of losses, tournament finish place there. And so we get all that information, then we're grouped by school so that we can calculate the whatever stats we want to by school. We're going to use this kind of strange, so we're going to throw it into a summarize. So this is now going to squash everything down so it's a single row per school, right? So that makes it a little bit easier for our table to deal with and whatnot. But we want to have all this additional information around the school, like all the years that they competed in the tournament and all that other stuff. So what we're going to do is we're going to use a list call. So list calls are a little bit funky, and they only work with tibbles. They don't work with data frames. So that is an important distinction to know. But what you do is you basically wrap whatever you're trying to create inside of a list. So like super simple, like that is kind of what you got to do. So what I want to keep here is I want to keep all the regular season win percentage values. So like this is a super simple case. All the regular season win percentage values for any time the school went to the tournament, and I'm going to throw it inside of a list. So that way I keep all those values, right? Then I'm going to use calculate the total number of times that school won the championship, and this is like our normal summarize. This is just creating a numeric value of the total number of times they were championship. Nothing too crazy there. But now we're also going to create, now this is like an HTML Unicode situation here where I want to put stars in for the number of times that they were championship. Make like a column that has stars every time they were championship. So what we do is here is I went and I found what the Unicode number is for a star in HTML. And what I do is I wrote that in there and say, okay, we're going to repeat yourselves the number of times that you were a champion. And so now I've got this vector showing this value n number of times they were champion. So like UConn was champion 11 times. And so it's got a vector of this 11 times, and I'm going to throw it then into a paste 0. So paste 0 is different from paste. So paste 0, what it's going to do is it by default doesn't add a space around what you're trying to add. So adding strings together, it doesn't add a space in there. I guess I could have done a paste here because I end up using this collapse. So when you put a vector into a paste, it's vectorized. So it's going to treat each record different or as its own unit, but with a collapse, it's then going to collapse all the values together as well. So it's going to basically put all the stars together into a single string of values. And then finally, years, which is really kind of like a summary of the data set. So what I wanted to do is I wanted to keep the data frame for that school and throw that into a list call. So in order to do this, I couldn't come up with a better way to do this. Lionel, Hadley, anybody else, maybe point me to a better way to be doing this. but I use dot notation to keep. So this dot here for when I'm using dplyr says, okay, now I want to keep the data set that I'm throwing into summarize here. I'm going to then subset to keep the school that we're looking at within this group summarize, ungroup it so that it doesn't keep the grouping with it, and then we're going to throw it inside of a list. So that's a little bit funky, but basically kind of think of this as I'm keeping the data that's the subset data for that school, and I'm throwing it into a list so that I can use it later. I think that kind of is a way to explain it. Then I'm going to ungroup the data set and then arrange by descending tournament wins. So like UConn has the most wins with like 11. And then I think the next is Tennessee, and then it's going to order by that. And so it's going to sort all that for us. So now we end up with the NCAA prepped data set here. So as you can see here, we've got UConn. They've shown up in the tournament 30 times. But if I go and look at NCAA prepped $ school summary, say I want to pull out like Baylor's school summary, so the win percentage over the number of times they've existed. So there, that would be a 3. It is, I can school summary 1. So this is all like the historical values that UConn had, I guess, because I did 1. If I did 3, this would be Baylor. So Baylor, the first year that they showed up at the tournament, had a win percentage of 72, then 83.
Regular season.
Yeah, regular
right?
season.
Yeah.
Yes. And then the last year they went to the tournament, they had a win percentage of 96. So this will be useful in the next step when we actually go to make the Reactable.
Yeah. So a bit of a funky code to get there, but it did what how many lines was that? That was like 22 to 30, so 15 lines. I think in the first iteration of something like this, I wrote like 40 lines of aggregating tidyverse code.
Aggregate this and aggregate that. Yeah, so list calls are incredibly valuable.
Simpler. Yeah.
Cool. All right, so now we're gonna jump into the table. Patrick, you wanna take us through this guy?
Yeah. Okay. So here we go. Reactable. We got our NCAA prep data frame that we just built, which contains all the lists of information. And then we're just going to select out the kind of critical columns that we want to use for this table. So the school, we want the number of tournament wins, we want the school summary, and we want the years. And now that we've got the information we need, we're ready to work the Reactable table. So Reactable is super easy. You could literally do Reactable parentheses and have nothing else inside of those parentheses, and it's going to give you a cool table that you can sort and look at and do all that stuff. And then if you want to dial it up like we did, there's a whole bunch of things you can do within inside that Reactable function. So columns, obviously, as the name would apply, is going to address the columns of the table. So you call columns, and then you call a list function, and then within that list function, you pass through the column name, and then you basically tell Reactable what you want to do to it. So that's with the call def, I'm guessing stands for column defined function. So for the school column, we're going to give it a name. We're going to call it school. So we just wanted to capitalize the S. We do want to make it filterable. So that's going to give like this little filter option at the top. And then obviously the width is as the name implies, the width of the column. The tournament wins, again, column defined. We're going to call it champs. That was just kind of a stylistic thing to shrink the column size down so it wasn't too long. HTML equals true because remember we're using that little Unix code for the stars inside of this column. And then a width is again, we're shrinking it down to 80, so we want it a little bit smaller. School summary is column defined. We're going to call this column win percentage history. And this is where we're going to dump our spark lines. So we did spark lines in a previous TidyX. They're a really cool way to put a simple data visual inside of your table so that the end user can basically get a picture of the data as well as the information if they wanted to look at the raw numbers, the values. So within this, and this is what makes Reactable useful and a bit funky and have a little bit of a learning curve, is there is some work to get this to fit, right? So I think in Formatable, which is another table package that we've used before, you could essentially just dump the spark lines in and it kind of knows what to do. Inside of Reactable, you have to write a little function. And if you wanted to do like conditional formatting of columns, you'd have to write a function. So it's a bit more of, here's Reactable and you create what you want. So we write this function we pass it two arguments, value and index. And then inside the function, we're going to call our spark line. We're going to take that NCAA prep data set, that school summary variable that was created, and we're going to take the index, and that's what we're going to build the spark line on, right? And the index is specific to, I think it was win percentage over time.
Yeah. Yeah. So basically, index is the row number that we're going to be looking at, right? So that tells it, okay, extract row 1 from NCAA prep school summary. So that is UConn's set. And then for row 2, grab Tennessee's. Row 3, grab Baylor's. Row 4, like, okay, so that kind of gives you that sort of information.
Yeah, and it's going to give us a basic spark line, which is going to be like a little area plot, which is a line plot with with a shading from 0 up to the top of that line. So that's what we're going to get there. Then we go to the years column. So we're going to call this summary. And again, a little bit of a function here. Again, value and index are the two arguments. So here's where we're going to use Ellis's package page table. So why don't you walk them through how your function that you wrote here within that package works?
Sure thing. Yeah, so page table, the point of page tables is supposed to look very similar to the tables that you see when you are printing a data frame in your R Markdown. So say you're working with, let's create a little chunk here, R, let's quickly change this. I don't like to print to the console normally, or inline normally, but like empty cars, right? So printing that out, you get this really nice data frame here. I think Javier Larashi actually wrote a lot of the code to help this, and then other folks at our studio really helped out with this. But what I like about it is it's paginated, so it allows you to kind of click through the various columns there, rows. But then it also is nice in that it lets you flip back and forth between all the columns too. And then it's reactive, so I make this smaller. Let's see now. There we go. So now it'll only display like these 3, but when I pull this out,
gives you more real estate.
It shows. So it fluctuates back and forth, and so I really liked that. So I worked with Javier and created page table to help with that. So let me quickly change this back from inline to console because I like.
So you wanted to use that inside of the Reactable so that the person has the opportunity to essentially have, however large or small they allow the table to be on their computer, they have the option to slide back and forth between the visible columns.
Exactly. So page table, so what it takes is the first argument is a data set. So we're going to select the NCAA prepped years. So this is the data frame, right, that we were working with. Kind of pluck that off and put that inside of the list. I'm going to remove school because we already know what school we're going to be working on. It's in the Reactable. We have that. By default, it tries to use row names. I don't want it to in this case because the row names aren't informative. It's like 1 through N, so it's not helpful. I'm setting the height. So this is an HTML widget. So Sparkline is an HTML widget, and so this is what needs to be coming out into cell out of this function is the HTML widget. So page table is an HTML widget. Row names, don't use them. I'm setting the height of the HTML widget to 200 pixels. You can set that to be whatever you want. And then I'm also going to limit the number of rows it shows to 5. Because otherwise, by default, it tries to show 10. We decided that, like for our purposes, for the table that we were looking at, that was too tall, too many rows. So then we're not going to output that. And so Now we've defined school, tournament wins, school summary, and years, and how they're going to look inside of our Reactable.
Yep.
Finally, we set bordered equals true because normally it doesn't show the borders between all the cells. We wanted to keep all those. And I also I set default page size to 5. So this will, by default, Reactable is also paged, which is pretty nice as well. Right now I'm going to limit it to be, okay, now only show 5 rows, and then page and 8 going forward. Let's build that. It's running. It takes a little bit because it's got to iterate through all of our data we've got going on here. And there we go.
Yeah, that's awesome. Yeah, I think you can zoom. The other thing that's super nice about this is with the export option, you can save this to an HTML file and email it off to whomever, and they have a interactive little web page that they can play with and search the data and all of that kind of stuff. So
boom, there we go. So this is what it would look like if you were to hand it off to somebody. So they could get a very quick look at, hey, look at the championships, like the number of times they were champs there. They can look at the history there.
Yeah, and they have the option there with the school. You can, so you're a big Washington State guy. Let's see how many times that they've gone to the. Oh, weird. Sorry. Bad
we
pick.
went to 91. We went to 91.
91. Yes, great year.
Go Cougs.
Nirvana Team Spirit broke in 91. Pearl Jam 10 came out. And Washington State went to the tournament. And they were out in the first round, I think.
Hey.
Well, look at UConn and Tennessee.
I'm proud of Washington State. Tennessee?
Yeah, like right there. Well, UConn was amazing. Tennessee, so I think most of those, maybe if not all of them, are Pat Summitt. She was like the legendary coach. Rest in peace.
Mm-hmm.
UConn is Gino Auriemma, who's I think probably surpassed Pat Summitt now as the most winningest. I mean, look at their line plot though. Like that's ridiculous.
Yeah, the last several years are 100%
100%.
here. So yeah, what I like about having this page, sorry, I just moved our little images now to the middle here. What I really like about having this table here that we can kind of sort through, combined with this, is we can go, oh look, wow, okay, wow, they're getting 100 here. And you can kind of look at the table and go, okay, with the last bit there, holy cow, the last 5 years, 2018 to 2014.
Yeah.
100, 97, 100, 100, 100.
Didn't lose very many games, did they?
Yeah, and then championship. They did lose.
What was
What was NSF?
I can't remember.
See, that's why having good levels.
I feel like the tourney finishes. It's such a non-intuitive. It was like such a non-intuitive thing for me, but.
Yeah, when I read it, I just did not. Let's take a quick peek. NSF. No, lost in the national semifinals.
So, semifinals. So that must be the final four, I guess.
Yeah,
in the tournament?
Semifinals would be final four.
Yeah, final four. Okay, so that.
Otherwise, they'd be N second, so national runner-up.
Oh yes. Okay, there you go. Yeah. So final four. Okay.
So
they could have just called it final four. Yeah. Okay.
Or some prior ones were like RF, which was the last 8 or the Sweet 16.
Yeah, something like that. Yeah.
Didn't make sense to me.
Elite 8, Sweet 16.
Yeah. But yeah, it's just insane.
Super
dominance there.
Amazing. Yeah. Pretty cool table though. Love it. It's awesome.
I love a lot of information here, but I think it's really easily parsable.
Yeah.
By people. Like you don't need to like have a ton of context around it. You're like, oh, Tennessee. Oh, I wonder what year how well they did in '83. Oh, look, they first seed, 76% winning percentage, RF, whatever that ended up being. They won twice, so they made it to the third round, so Sweet 16.
Yep.
There you go. So great way to super cool table. Love how it works. Thank you, author, for working on Reactable. Please continue to work on it, and I'm really excited to see where this thing goes.
Yeah, super cool.
Cool. Well, with that, I think we can call it.
All right. Well, that was Tidy Explained, episode 31, Reactable. My name's Patrick Ward. You can find me on Twitter at OSPPatrick.
And my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes. You can contact the both of us on Twitter at tidy_explained, or shooting us an email at tidy.explained@gmail.com, or leave a comment in the comment section down below. And as always, keep on exploring your world.